Hi, my name is Vahan Davudyan. I'm a physics experimentalist for 30 years, and today's topic is going to be color perception. First of all, I'd like to thank so many people emailed me. We had 4 comments, and then thumbs up, and then subscription also. So rewarding, and I appreciate that. The feedback is so important. In physics, there's a concept called, oscillation. If there is no feedback, there is no oscillation. The best example is the pendulum. If you don't have any feedback, the pendulum will stop. So your feedback is extremely important, and always I make sure that I read everything, especially the emails. Then I take action after that, because it's so good. You guys are not criticizing, but you have a good ideas. Most of the time I put it to work. Sometimes I'm acting like a computer, get all your feedbacks, and then I process, I analyze it, and I come up with a good answer. And you know what? Do that, and because this is the way we can promote the science. And in fact, today this color perception is extremely important, and it's called Color Perception by Vahan Davudyan, physics experimentalist. And this is my email, vahandavudyan 1948 at gmail.com. First of all, I like to thank to famous doctor, English doctor. His name was Thomas Young, and maybe you guys remember he was so famous because he was the first one with the double slit experiment. He proved that the light is electromagnetic. And then I will explain the human eyes, how it works. And the contribution of Dr. Thomas Young was amazing. He discovered in a human's retina there are some, cone cells, which is so important. And those are the ones who are activated or stimulated by red, green, and blue light. That's why we can see the different lights. And about, there's so much science, but as I go, I will explain step by step. So we have those cone cells in our retina, but this is the human eye. Well, of course, it's so complicated, but I go with the basics. When the light comes in, then we have the cells over here. Well, of course, it doesn't show in this picture, but amazing thing about the human eyes is that why are we using nanometers? And sometimes I think that the human eyes are like nanotechnology, because we have 3 different colors, or the main colors. We have red, green, and blue. And the red is like they start from 400 nanometer all the way to 700 nanometer. And the red is 600 nanometer, the wavelength, and the green is 550 nanometers, and the blue is 450. But the amazing thing is, our eyes is doing that, immediately, or is instantaneous whenever one of those cones are activated, so we can see red, we can see green, or we can see blue. Sometimes I think that, human eyes, we're using nanotechnology because it's dealing with nanometers. It's a billionth of a meter, and it's amazing how the human eyes works. So I had to have this graph so you can see. It's a start from 400 nanometer to 700. Then you can see green is almost like 500, and then blue is almost like 400, and the red starts from 700 to 550. And you can see our eyes distinguish everything. And brain, it's so complicated, I don't know how it does it. A brain interpret that this is a red, this is blue, and this is. If you have a look over here, you can see this iris, and this exactly I compare with the camera, and this is like an aperture when the light comes in. This with the cornea, they are focusing everything, the light comes in, and they get the amount of light comes in. Well, of course, the human eyes is much better than the camera, but I remember I worked in photography for 10 years, and this is exactly how it works. The light comes in, so these cones are activated. That's why we can see. Well, of course, I have some experiment also. I show you. So this is so important that you guys, distinguish between the colors. So we have primary colors, we have green, red, and blue, And these are additive because they add up. I will explain what do I mean by they add up. We have also subtractive colors, yellow, magenta, and green. One amazing thing about this thing, most physics books, they have these pictures. Some of them are in black and white, but some in color. But you can see green is overlapping the red overlapping the blue. So they all overlap. So what happened, in the center we get white. You see this rectangle over here, we get a white color. But amazing thing about this is, if blue overlaps the red, we got magenta. See, you got, if blue overlaps the green, you got cyan, and if red overlaps the green, we have yellow. And I mean, there is no exception. Always it does. And then these are the subtractive colors. So we have yellow, magenta, and cyan. So what happened? Cyan is filtering, or absorbing the red. So, and then red reflection is absorbed, and magenta is absorbing the green, and yellow is absorbing the blue. So, like I said a few minutes ago, if you add red plus blue, we get magenta. If you add red plus green, you get yellow. If you have green plus blue, we have cyan. So these are the basic colors. And then I have experiment I show you. Let me take this off. Most physics books, what they do, they have the pictures, but this time I realized the picture, some people won't be able to visualize exactly what we mean by that. So I had to get this, I have 3 LED lights. So I have red, green, and blue, and they are real bright light. And light is the only way you can see if the, add the how do they add, so how the cyan and the magenta and the thing work. Okay, I have to put this white background so you can see this experiment, which is so easy to understand. So we have green color. Okay, now we have a blue color. See, we get, if I do this, if I activate these two, so in between you can see they overlap each other, that's going to be cyan. Now if I have all of them activated, you can see what happened. So we got white. See? We got white in center, and then here we got magenta, we got like a cyan and yellow. And this is the only way you can see the the lights are much better, so you can distinguish. If I rotate this, it doesn't matter. Always, center is white. Well, of course, I have to focus this a little bit, and then you can see on the side we have the primary colors, but when they overlap, so we have yellow, we have cyan, and we have magenta. Well, of course, I have to mention this is so important. And the first time Mr. James Clerk Maxwell did this in 1840, and he was amazing scientist, and he did this by those toys are you can call it they call it top. So he had 3 colors on the top on the top. So he just spin that. And then well, of course it wasn't 100% white, but I came up with my own idea. Let me show you this. I had to put this on an electric motor, and then you can see that combination of 3 lights, you get white color. So you can see I have like 120 degrees. I have green, red, and blue. When they rotate together, well, it's not 100% white, but it shows the concept of what Mr. James Clerk Maxwell did in 1840. That makes sense. Well, of course, I have the same disc. I have like a blue and red, so that makes it magenta. So you can see this is another way you can visualize. So as I said a few minutes ago, cyan subtract or absorb the reflection of red, magenta subtract or absorb the reflection of green, and yellow subtract or absorb the reflection of blue. So what it is, you can see this young man over here, he's thinking, why do I see this apple red. So what happened is colors are absorbed, but the red is reflected. So why do I see the leaf green? Because all those are absorbed, but the green is reflected. And this happens, instantaneously in human's brain. And if you have like rainbow color like this, in a fraction of second you can see this red, orange, yellow, green, blue, or indigo, or violet, because they're so important that you can distinguish between these colors. So I'm hoping you guys enjoyed this video. It was concise, coherent, and logical. It was like a short, so I'm hoping that you guys like it. If you like it, you can subscribe it, and then if you have any comment, you can write it down. It's so encouraging for me. I love those. I take action on those, and always I take that into the consideration, because your feedback is extremely important for me. Thank you for watching. Appreciate it.